Today we are going to discuss about the Kirchhoff junction rule and Kirchhoff loop rule. Based on this, we are going to solve some numericals in this class. So first we are going to start with Kirchhoff junction rule. I can simply write junction rule. So I have three resistors. So the current entering here is going to be I1, the current entering into through the resistor is going to be I2, the current is leaving from this resistor is going to be I3. So I can simply write the net current at this point P is going to be 0, which means the amount of current entering the junction that is equal to the amount of current leaving from the junction. So I can simply write my I1 plus I2 equals to I3. So this is your Kirchhoff's junction rule in the current electricity. So the amount of current entering the junction that is equals to the amount of current leaving from the junction. So this is called your Kirchhoff's junction rule. Next we have a rule, Kirchhoff loop rule. So I can simply write my loop rule. So as I am going to consider a loop with two resistors. It's connected with a cell of EMF 5 volt. This 2 ohm is going to be 3 ohm. So what my Kirchhoff loop rule says, the potential drop around any closed loop is going to be 0. So the potential drop around the algebraic sum of the potential drop around the closed loop is going to be 0. So listen carefully. So whatever the potential I applied here, this potential should drop across this resistor and this resistor. So the potential drop across this resistor plus the potential drop across this resistor, it's equal to my applied potential. So I can simply write here, I'm going to consider my point A, B, C, D, right? So the current is leaving from here is going to be I, the current is entering is going to be also is going to be I. So since it's a series combination, there is a splitting of your current, the current entering from here to here. So I can simply write that my applied potential for I'm going to consider loop A, B, C, D, right? So this is my loop direction is in the clockwise direction. My current also the clockwise direction. When this is the positive sign, the current is leaving from the cell. I can simply write 5 minus the potential drop across this resistor 2 into I. 2 into I. And then the potential drop across this 3 ohm resistor, I can simply write minus 3 into I equal to 0. Listen. So what are the potential applied here? This should drop across this resistor as well as this resistor. This term is nothing but the potential drop across 2 ohm resistor. This is my potential drop across my 3 ohm resistor. So my potential drop across the total system, the potential drop around the closed loop is going to be 0. If I am considering the other loop, the ulta. So I can simply consider the loop of DCBA. If I consider the anticlockwise loop. So for example, if I am considering this loop here, I can simply write, so actually my current should be exactly in the opposite direction in this case, right? So I can simply write here minus of 5 plus 2I1 plus 3I equal to 0. So this is equal to this, only the plus and the minus sign is changed. So my ultimate aim is the algebraic sum of the potential around the closed loop is 0. So next I will solve a problem, then you are able to understand easily. In this problem, we have two cells. E1 is 12 ohm with internal resistance R1 equal to 2 ohm. So we have a resistor R 4 ohm and we have another cell with the EMF of 6 volt and internal resistance 1 ohm. So my target is to find the potential drop across this 4 ohm resistor as well as the power dissipation across this resistor. So to solve the problem, first I am going to find the current through this 4 ohm resistor. So the current is leaving from here is going to be I1, the current is leaving from here is going to be I2. Listen, since it's a higher potential, okay, this is also higher potential. So with respect to these two cells, this is my low potential. So the current entering here equal to I1 plus I2. The amount of current entering is going to be I1 plus I2. So the current passes through across this 4 ohm resistor and then again it's going to be split. the amount of current entering into this will be I1, the amount of current entering through this will be I2. So the amount of current entering the junction equals to the amount of current leaving from the junction using your Kirchhoff junction rule, right? So I'm going to form a loop to find the magnitude of the current. So to find the magnitude of a current, I can simply write with A, B, C, D, E and F. So what I'm going to do here, I'm going to construct two loops because I just want to find my two unknowns, I1 and I2. I have two loops. So I can simply solve the problem here using this. So I'm going to consider the loop of A, D, C, B. So loop A, D, C, B. I can simply take this is my loop direction. So loop direction in the anti-clockwise direction, the current is also in the same direction plus. Listen carefully. So the current is leaving from here is 12. So the loop direction and the current flows through the 4 ohm resistance also in the same direction. Same direction, subtract. So minus 4 times I1 plus I2. So with respect to this resistor, here also the current in the same direction. So I1. So the potential drop across this, I can simply write minus of 2 into I1 equal to 0. So if I simplify this here, I am getting my 12 minus 4 I1 plus, minus of 4 I2 minus 2 I1 equal to 0. So 12 minus 4 minus 6 I1 minus 4 I2 equal to 0. Then I can simply write minus 6 I1 minus 4 I2 equals to minus 12, right? Yeah, I can simply write 6 I1 plus 4 I2 equals to 12. This is my equation 1. So this is the equation I am getting from my loop 1. So next I am going to consider the second loop. So loop, listen carefully, I am going to consider this loop. A, D, E, F, this loop. Okay, so A, D, E, F. And you can consider any direction of the loop. Okay, so you need not to consider clockwise and anti-clockwise. It's depending upon your requirement. Okay, so in this case, I am always choosing the current is leaving from the cell. It's easy to solve the problem. So the current is leaving from the cell is this is the clockwise direction. In this case, it's in the anti-clockwise direction. So that's why I choose my loop here. So I can simply write here from this loop is current is leaving. I can simply write 6 minus. So loop direction and current direction are the same. I can simply write 4 times I1 plus I2. Listen, here also the current is entering here. So it will be I2. So the current direction and the loop direction is the same. So minus of 4 times 1 into I2 equal to 0. So the sum of the potential around this closed loop is also going to be 0. So 6 minus 4 I1 plus, this is going to be minus 4 I2 minus I2 equal to 0. Then I can simply write 6 minus 4 I1 minus 5 I2 equal to 0. So I can simply write this equation 4 I1 minus plus 5 I2 equal to 6. This is my equation 2. So this is my equation from the first loop. This is my equation from the second loop. By solving this equation, I can find my I1 and I2. So if you want to solve the problem here, so this is this. I just want to find my I2. So what I'm going to do, I'm going to remove this I1. So this is multiplied by 4 and this is multiplied by 6. Then I1 gets cancelled. You can find I2. If you want to solve this problem, this is 5, this is 4. So this is multiplied by 4 table and this is multiplied by 5. Then I2 gets cancelled. You can find my I1. So I can simply write the value of I1 and I2 from here. So my I1 equals to, I just write it from here, my I1 value here 18 by 7 ampere, and then my I2 value here is going to be minus of 6 by 7 ampere, minus of 6 by 7 ampere. So I just leave this as an exercise to you. I just leave this as an exercise to you. So my current need not to be positive in every time. My current may be in negative also, right? So I have my I1 and I have my I2. So using this I1 and I2, I can find the potential drop across my 4 ohm resistor. So my potential drop across 4 ohm resistor, I can simply write 4 into I1 plus I2. Then I can simply write 4 into I1 is 18 by 7 minus 6 by 7. So you can find your potential drop across the 4 ohm resistor, and then the power dissipation through the resistor. So joule heating, okay, I square R. So I can simply write the power dissipation through 4 ohm. I may write this equation as I1 plus I2 square equals to, into I square R, right, into 4. So it's going to be 18 by 7 minus 6 by 7 square into 4 ohm. So I just leave this calculation as an exercise. So this is how we are going to use the Kirchhoff loop rule. So Kirchhoff loop rule is to find the magnitude of the current in each branch of the circuit, right? In this problem, they are given the EMF of 3 cells. E1 is 2 volt with internal resistance R1 equal to 4 ohm, E2 equals to 1 volt with internal resistance of 3 ohm, EMF of 4 ohm with internal resistance 2 ohm. In this problem, the current direction is given in the problem itself. So we need not to change anything, right? We need not to predict the direction of current. So the current direction is, the current is leaving from the higher potential cell, 3 ohm is I3 is given. So my target is to find I1, I2 and I3 using Kirchhoff loop rule. That's it. So at this point, the amount of current entering the junction, that is equal to the amount of current leaving from the junction. So using the junction rule, I can simply write my I3 equals to I2 plus I1, right? So I1 plus I2, I can simply write. So I am going to form a loop A, B, C, D, E and F. So I am going to consider a loop here, be something like this, right? So for this case, in this loop we have 2 cells. 2 cells in the loop, we have to solve the problem carefully. So the loop, if the positive terminal here are on the same side, we have to subtract. So in case if there is a minus sign, if there is a plus sign, we have to add. So same side subtract. So for this loop, I can simply write the current entering here is going to be I1, the current entering is going to be I2, the current is entering is going to be I1, the current is entering here is I2, the current is leaving is going to be I3. For this loop, for loop A, B, C, D, I can simply write, if we have 2 cells here, same side, this is also positive and this is also positive, same side subtract. So I can simply write 2 minus 1. So the current through this is the same direction, minus of 4 into I1. So again here my current direction and the loop direction exactly the opposite direction, plus 3 I2 equal to 0. Then I can simply write it's going to be 1 minus 4 I1 plus 3 I2 equal to 0. Then I can simply write here minus of 4 I1 plus 3 I2 equal to minus 1. So I can simply write 4 I1 minus 3 I2 equals to plus 1. This is my equation 1. So this is the first equation from the first loop. Next I am going to consider loop this direction, right? So here we have 2 cells. So this is also positive and this is also positive. So these two positive are in the same direction. So same side subtract. So I am going to write high potential minus low potential. So I can simply write for the loop A, D, ADEF. ADEF. Okay. So high potential minus low potential. 4 minus 1. Sure, here the loop direction and current direction are the same. So I have to use negative sign. Minus 3 into I2. Here loop direction and current direction also is the same. So I can simply write minus of 2 into I3 equal to 0. So it's going to be 3 minus 3I2 minus 2I3 equal to 0. So minus 3I2 minus 2I3 equal to minus 3. So 3I2 plus 2I3 equals to 3. This is my equation 2. So this is the equation formed from my equation loop 1. This is from loop 2. By solving these two, we can find my I1 and I2. If I add my I1 and I2, I can find my I3 value. So by solving my equation 1 and 2, simply just add these two. I2 gets cancelled. Then you can simplify and find the value of I1, I2 and I3. I1 equal to I2. I3 equals to I1 plus I2, right? 13 ampere. So if I add these two, I am getting what? 9 by 13 ampere. So it's easy to form a loop and then you can write the equation. Once you are writing the equations here, equation 1 and 2, how many number of equations we can form? So it's depending upon your problem. In the problem we can find, we have only 2 loops. So if you have 2 loops means we can find 2 unknown parameters. So it's easy to solve the problem. So once you form the loop, you can write the equations. Then after this equations is just a mathematics. Okay, so you can solve and you can get the results in the different branch of the given circuit. So I just stop at this point. If you like this video, share it with your friends and subscribe to the channel for the more content. We'll meet in the next video. Thanks for watching.